Okay, if we can take our seats, we can continue. Sorry for a bit of the delay. We had to set up the next presenter. Not to lose any time, and we all want to have a coffee break. The next presentation is by Micky and Neo 10, the plugin at Caphaw, also known as Shylock. Just take it away.
Hi, my name is Micky, and this is Neo. We are both doing botnet research in Fortinet. Today, we are going to talk about one of the most high-profile banking Trojan botnet in the past few years, Caphaw. For today's agenda, I'm going to give a brief introduction of what Caphaw is. Then we'll be going to talk about goals that Caphaw focuses on and their aggressive approach to address them. I would also like to briefly summarize the campaign of Caphaw on how it has evolved over time. Then I will hand over to Neo to talk about how Caphaw works in detail, focusing on its C2 network infrastructure, communication protocol, and encryption, server requests, plugins, and configuration file. Then I will conclude today's discussion of Caphaw with a few observations and current state of this botnet. We have collected our first Caphaw sample in late 2011, around November. Caphaw was commonly known as Shylock because its early sample contains quotes from Shakespeare's Merchant of Venice as its issuer. Caphaw was well known as for its man-in-the-browser attack, which targets bank websites. Caphaw has caught public attention in early 2013 because of its release of Skype Spreading module, noting that MSN Messenger and Skype service merged around that time. We have also discovered that in the later version, Caphaw copied significant amount of code from Sue's source leak. Caphaw had operated for roughly 3 years, and it has not been seen on sale on the black market. There were no source leak of itself. This suggests that Caphaw was privately owned and ran by the same group of people who were actively developing them. So let's talk about 3 goals that Caphaw attempts to address. The first goal is to get new victims. The malware relies on a network of infected websites to perform drive-by downloads attack as its initial infection vector. For directing traffic to these sites, one way to do it is through messaging service such as MSN Messenger or Skype. Once it is resident on a newly infected machine, it will go find the specific messaging application, and it will use it to send malicious link to the victim's contacts through the chat function. Likewise, Caphaw can also spread by hijacking Facebook account and posting malicious link into friends' walls. They had also been seen using malvertising, spamming, and other botnet in distributing the Caphaw client. The second goal of Caphaw is stealing banking information. Caphaw has built-in code and plugin modules to accomplish this mission, such as taking video of the desktop, keylogging, installing VNC server, hooking up the browser to upload the browser cookies, or make phishing sites locally available through the infected browser. The final goal of Caphaw is to maintain its control on its botnet terminal while being stealthy at the same time. Caphaw was designed to protect itself from being discovered or reversed by having code to detect sandboxing and the debugging environment. It has also tried to impede the process of reverse engineering by code obfuscation and traffic encryption. Using all the samples we have collected, we have constructed a timeline for Caphaw's build version number against sample collection date. The malware writer has been actively updating its client for roughly 3 years. We have collected our first batch of samples in November 2011, marked as version 1.0. All the malicious strings are revealed once unpacked from the custom packer. The original client also only has a master and slave installation mode, which we will be discussing that later. In June 2012, Caphaw had a lot of major updates in its 1.4 version. Caphaw has added anti-VM mechanism by checking VM presence in system module, register key value, or running processes. Caphaw has also added anti-debug mechanism by making sure that the first time the client is run is within 2 hours after the client was built. Caphaw had been rewritten to accommodate copied code from SUSE. The code they copied from SUSE included antivirus processes detection, string encryption, and API hash encryption. In February 2013, there was a version 1.7. Caphaw had added Skype message spreader module as a download. It has finally gained a lot of media's attention because Microsoft has scheduled Skype to replace MSN Messenger at that period of time. In February 2014, there was a minor improvement in Caphaw's string encryption algorithm. This version had taken out the 4 zeros, which originally separated the key and the encrypted string. This has made the client smaller and at the same time making it harder to crack the code using 4 zeros as an anchor to apply decryption method that will reveal all the malicious strings. There are also a few kind of update in client code through the whole timeline. It is the XML tag in the configuration file that can be parsed by the client. We have observed certain modules that comes with the tag being introduced in the later version, whereas some other tags were obsolete or available as a downloaded plugin in other versions. Now I'm going to hand over to Neo to discuss the details of Caphaw client.
Okay, now the fun part. Caphaw implemented multi-processes and multi-threading architecture in order to distribute the workload and to run efficiently. It tries to inject itself into multiple processes, including Firefox, IE, Explorer, SVC hosts, and so on, depending on the variants. To intercommunicating between these processes, it creates a name pipes using names uniquely generated from the user environment. There are 3 installation modes or injection mode: master, slave, and plugin. This is a typical control flowchart of the master mode installation. The master process was mainly responsible for the initial contact with the C2 server and injecting the slave process, sending initial report, and to get the initial configuration data. Once the configuration was downloaded to local, it parsed it and might inject more processes to start the plugins. The slaves and the plugin process also had the ability to communicate with the C2 server, pass the communication file, and to load corresponding options. If this may sound a little bit complex, let's just think of that all these processes will act like a unity process with multi-threading function here. It will help you to understand the following concepts. So, how did the bot find its C2 server to start the initial contact? This is usually I like the most. Because for the botnet writer, the most concern is to protect or to hide the C2 server infrastructure. Almost every bot has its own way of finding and updating C2 server or proxy server list. So there are some examples. I call it, the first one is the hard way. They encrypt and hard-coded the C2 server list inside a client binary, such as Andromeda bot. So the downside is quite obvious, because if the bot loses connection while the server changing the domain name, then the bot does not get the update, hence it's lost forever. But there's the upside of it. It is not easy to track the latest server list if you don't have the latest bot client. And the next one, I call this software, such as Zbot, Quedex, and Kraken botnet. The client and the server are both using the same domain name generating algorithm with the same seed, so that the generated domain name is actually not random, but predictable by both parties. Commonly, they use current time in a specific time zone for the seed. Therefore, even the server disappears or lost communication with the client for a period of time, when it comes back home, it still knows the currently active domain it should register, and vice versa for the client. The downside of doing this is that once the domain name generating algorithm is reverse engineered, you can just filter out all these possible domain names in the ISP or the domain name server level to disrupt the botnet. What Caphaw used for the C2 server connection is a combination of the 2 ways together with the configuration updates. Here's in the middle, here's a URL template for the client to connect. The initial domain name were hard-coded in the binary, the client binary, encrypted. And the subdomain was going to be randomly generated. Here's the lower part is a pseudocode of the get prefix, the get subdomain name function. The bot used this function to generate a random subdomain name. Note that the count random here was going to generate arbitrary numbers constrained by the variable count, the child count max. And you use a random C as an input inside this function. So the client would keep trying the generated subdomain until it could get a DNS response. As you can see in the Wireshark snapshot above, the bot tried a bunch of subdomains until it hits the DNS query response. So for now, it looks like the bot is shooting a shotgun blindly and wasting time doing all this meaningless effort here. But actually, it's not. Here's a communication protocol and encryption. For communication protocol, the botnet uses secure sockets layer, and on top of that, the post message is encrypted using RC4 algorithm with key being the domain name it was querying with the fixed string appending to it. And some of the variant uses server IP with the prefix as the RC4 key for the encryption. As you can see, the prefix is always a part of the RC4 key. The idea is that it was the C2 servers to decide which subdomain it was going to use, and only the right client which had the right subdomain generated could be able to start an initial communication with the C2 server. So if you, for some reason, know the C2 server IP and try to connect to it, but without knowing the prefix, you cannot start a communication. And the message sending back from the server to the client was also encrypted using RC4 key with a different key, being the ID value generated using CPU ID instruction and hashing function. How did the server know this ID, this RC4 key? It is in the initial request. Here's a list of parameters and descriptions of the data sending to the server. So you can see there's a key vendor, which is the first one, the vendor key, and the ID, which is going to be used by the server to encrypt the message sending back to the client, and the installation mode, and also the botnet name. And the CMD and the W here together indicates the message type. For example, CMD equals to log and W equals to compare info, means this message contains a report of the infected host. And COLS means stolen flash cookie files. And RQT means stolen Bitcoin wallets. And here are more parameters. The version here is what we use to construct our timeline. And here's an example of a request being sent from a master installation mode process inside a botnet named USA and requesting for a configuration file. And the bot collected an extensive user information from the local host. Here's the list of the information collected. Most of them could be used for user profiling and victim selection. And there are some interesting ones, the list of anti-malware products and whether it is running in a sandbox environment. If it found any inside this report, the server might reply back your fake configuration file instead. So as an analyst, you might be playing with the fake downloading URL and got nothing. Now I will hand over the rest of the presentation back to Micky.
As I mentioned in the earlier session, Caphaw had employed a wide range of strategies to achieve its goal of stealing banking information. A lot of these functions were not presented in the original Caphaw back in 2011. They were added slowly later. Since Caphaw uses namepipe to communicate between infected processes on a compromised machine, plugins were able to install using a newer configuration file and still being compatible to Caphaw client that might not be the latest one. So here is a list of plugins that we have seen being downloaded by Caphaw. It had a browser cookie stealer, which extracts information from the browser cookie database and use the Caphaw's built-in archiver to compress it and upload it. The archiver also does the same kind of thing for desktop screenshot videos. There was also a VNC server which makes remote accessing the computer available. FTP Grabber took the login credential stolen in the infected machine from certain application and uploaded it to the C2 server. This spreader copies the Caphaw client to removable drive or network shares. There was a SpamBot plugin that uses the infected machine to distribute Caphaw client using downloaded spam templates. And there's a Backsock, which is a proxy server plugin that uses the infected machine as an access point to bypass internet filtering. The last plugin, Skype Spreader, was the most interesting one, which makes Caphaw stand out as a banking Trojan. So the Skype Spreader first checks for the existence of Skype application in the infected host. Then it tests for the connectivity to the Skype C2 server. The URL address of the C2 server is provided by the Caphaw configuration file, which we will be seeing that in the later slides. Next step, it disables the sound alert of the Skype application and send an HTTP request to the C2 server and retrieve a list of options on how they want the Skype spreader to be run. Let's say by using the wait away option, Skype spreader will be sleeping for a hard-coded amount of time before it starts spamming its contacts. The Skype spreader hooked the Skype window using Skype Control API Discover and Skype Control API Attach. However, this will trigger the TSAP communicator window to appear, as you can see here. To quickly get rid of this window, the Skype spreader will do some calculation on where the Allow Access button was located in this window and send a left mouse down event to make it go away. With the authentication feature of Skype thrown out of the window, Skype spreader proceeds to retrieve the spam template from the C2 server by sending a @user HTTP request. Then it will use this information to spam all the contacts in the infected Skype user, like this. The last step of Skype Spreader was to clean up the Skype history database of its spam messages and send an all done HTTP request to the C2 server. I would also like to point out that NGRBot was using a similar technique to spread their malicious software around the same time. However, this version of Skype Spreader we're seeing here are far more sophisticated since it worked with Caphaw configuration file and it requires to connect to a C2 server. The NGRBot Skype Spreader, on the contrary, had everything hard-coded in its spam including its spam template in their Skype module. Now we are moving on to talk about Caphaw configuration file. After Caphaw client is ran the first time on the machine, Caphaw can inject itself into an existing process and install itself into these processes under different modes. There are restrictions on how these scattered processes on the PC read the configuration file though, as it is indicated in this table here. In each infected PC, there are only one master which must not be injected into the browser process, such as iExplorer.exe or Firefox.exe. The master process main responsibility is to keep track of the C2 server information such as URL update and keep track of other Caphaw infected processes in the PC. The infected process with slave installation mode could only be the browser processes though. Hence, it focuses on parsing information in the HTTP tag that contains information on how to do web page injection on specific pages. The plugin installation mode is used on all the downloaded modules. Hence, these processes are allowed to parse all the text that are related to the extra functionalities of this bot. Here is what a Caphaw configuration file looks like. It contains the information about the botnet C2 server. The other part of the configuration file will include instruction to run the built-in modules. It also includes information regarding plugins, its download location or initial state after installation. Last and the most important part of the configuration file is the HttpInject tag. The downloaded HttpInject file is another XML format configuration file encrypted using the same method. Now we are going to discuss further about this file. This configuration file is written to work with the hooked browser such that it could manipulate information in the browser based on an event detected, such as alert box or URL visited. Based on these triggers, the hooked browser will use the configuration file's instruction to either inject script into the page or replacing certain string in the loaded page, which I will be demonstrating in the later slides. The URL visited or event can also trigger other modules of Caphaw to assist in stealing user information, such as logging the URL visited, grabbing the forms, initiating VNC session, and so on. It is interesting to point out that when the hooked browser detects the user is visiting the business subdomain of a bank page, the configuration file will enable the back connect server because the malware operator might think that the user is accessing from a corporate environment, and it will be easier to send back useful information to the C2 server if a proxy server has been set up. From the HttpInject file, we can see that it was trying to replace bank helpline numbers such as credit card fraud number to their own, so that when the victim tries to call and report suspicious behavior in the account, they would end up calling an answering machine. Another thing is that the HttpInject configuration file can also duplicate important input boxes and hide the original ones such that it can use extra JavaScript to retrieve the user's input information and send it back to the 2C server. If all the keyloggers or form grabbers doesn't work on certain bank websites, there was also a module which captures the PC desktop into an AVI video and upload it to the C2 server. We have made a summary of all the banks being targeted by Caphaw from all the HttpInject configuration file we have collected. There are about 23 US-based financial institutions, 28 from Italy, and 27 in UK. And there are also mortgage loan companies, credit card services, US retirement saving services, and treasury management services. There are also some unlikely targets being discovered through these HttpInject configuration file, such as a library website, a job search service, and an Italian communication company. The configuration file will just instruct the hooked browser to log these URL visited. For the case of the job search service website, the configuration file wants to log the URL only if it contains the search parameter, which most likely will be containing information regarding job search. We suspect that this information could be used against the victim by sending them better craft phishing emails or use it as a filter to data mine victims who might be searching for a higher paid job. In the month of May 2014, there were 12 C2 servers in the United States, and the rest of them are mostly located in European countries. Based on our observation, Caphaw requires two groups of people to work on some time-consuming tasks for the botnet. One group will be the developers, who are responsible for updating configuration file to combat online banking security countermeasures or withdraw from difficult targets, building new client to include the latest active C2 server domain, updating the client with original code or copying rival botnets code, and adding new features and plugins. There will be also a group of people who will be busy data mining for bank and credit card information, filtering out worthy victims from special browsing history, monitoring VNC sessions, or reviewing screenshot videos. Finally, I have a few last words about what happened to Caphaw now. Our botnet tracker has suddenly stopped all connections with C2 servers in June 2014. After 3 years of operation, multiple presses has reported that Caphaw or Shylock was taken down by multi-agency joint effort in July 2014. Seizure of C2 server lead to discovery of Shylock infrastructure. I guess cat is out of the bag by then. Last but not least, no report of arrest has been made so far. Thank you.
Okay. Thank you for the presentation. We have like a minute or two for questions. Are there any questions? In the middle?